Okay, so I'm going to make a quick demo video here on doing some hot air welding with some FDM parts produced in the FDM 3D printing technology. So what I'm doing here is I'm using the plastic filament that the machine uses to build as a filler rod, and I'm going to weld the parts using heat from a hot air gun. What I'm using here is a Leicester Hot Jet S. It is temperature controllable and airflow controllable, so you can really dial it in of exactly how much heat and airflow that you want, which helps you to get the right penetration and heat for different materials. For this particular part is ABS, and I'm welding it with blue ABS filament just to show the contrast. And I'm going to use a heat and air setting of 2.5, and I'm using a fairly small little oval shaped air tip. It's probably 1.5 millimeters wide and maybe 3 millimeters long. That's really about the ideal size of tip that I've found for doing this size of welding. So basically what I'm going to be doing here is I need to use the hot air to actually heat up and melt the actual part that I'm welding, and at the same time I need to put heat into the filler rod to make that melt and flow into that molten pool of plastic that you've created on the part. And I'm going to be pushing the plastic filament into the part and digging a channel into the part with the plastic filament. So I'm actually penetrating this probably a good 2 or 3 millimeters into the part and leaving some of that filler rod behind as I'm doing that. So you'll see me moving the air around to control how much heat I'm putting into the part and how much heat I'm putting into the filament. And that's just something that comes with practice. You have to do it for quite a while to really get proficient at it. Actually, I haven't really done this very much for quite a while. It's not really in my job anymore. But I used to do this all day, every day, but I haven't done it for probably about 2 years now. So I'm actually pushing down fairly hard on this plastic filament. Basically, is just about as hard as I can push on it without, buckling the filament. So I'll just get started. So to start, I need to kind of warm up the area of the part that I'm heating here. And this white material can discolor a little bit, but that will sand out. It's just on the very surface. So now I've heated up the part. I've got a small little part of the part that's good and hot, and now I can start heating up the filament and getting the filament in there. So right there, I've kind of stuck the two together, and I didn't really get a good penetration in there because I just wanted to show you how I'll make that initial stick that I really want to get both of those melted, because otherwise you'll end up with a little spot at the start of your weld where the filament isn't really adhered to it. So I'm just going to start this again. So you should see how that filament is actually making a mushroom, and camera might be a little bit too far away to see, but you'll actually see that I'm displacing the white base material out of the way of the blue filament. So if I were welding this in white colored part and white colored filament, this discolored plastic material actually gets displaced out of the way, and it kind of sits proud of the surface, so it could just be sanded off. Just try to bring in that in for a little bit of a close-up there. So yeah, as you can see, the plastic filament is actually mushrooming out in a circle around that filament because I'm pushing straight down against the part with the filament, and then just kind of leaning it over just a little bit to get it to travel in the direction that I want. But 95% of my force is pushing straight into the part. And you'll also see, like I mentioned, that the white material is actually flowing out of the way of the filler filament. And this sits proud of the surface here, So when I'm done with this, I'll take a DA sander or a file or a chisel or whatever, and I'll knock down that weld bead. And because we're actually penetrating the weld into the part, I can make this flush, and the part will still be strong because it has a good 2 or 3 millimeters of weld bead embedded into the part. So I'm just going to weld one more small little bead on here. So I'm going to heat up the part, and I'm just going to start to kind of heat up the tip of the filament. And once I get them good and warmed up, I'm going to get a nice melted spot, a little more heat, and stick that filament in there and just push it down and just drive it into the part. And I don't really start moving forward until I've pushed hard enough to get that driven into the part. And I like to kind of just make a rhythm of moving the heat gun back and forth, of focusing the heat right in front of the filament, and then just putting a little bit of heat right on the filament itself. And I just kind of, it's probably imperceptible to the camera, but I'm just kind of adjusting that rhythm as I need to control how much heat I'm putting into the part and into the filament. So that's really all there is to it. It's not a very straight, clean one. Like I said, I don't do this every day anymore. But that's all there is to it. Now, just to move on, I took this part, which this was just a scrap part that I just took out of the dumpster. It had a build failure on another area of this part that I cut off. So I actually cut off this section of the part and this section of the part in a bandsaw, and then I just cut this squiggle line through it with a bandsaw. Normally, if I'm sectioning parts to build in pieces, I like to use some little like dovetails or little notch features. That makes it really easy to align it and get it all together and weld it. And also it gives some shear strength to the joint. You don't want to just cut something in a straight line and try to do a butt joint, because then you don't have anything to keep that butt joint from going like this. But if you put something interlocking in there, which can even just, like in this part, I might just put a little square notch and then keep going across the part, and then just one more little square notch, and then maybe in the side I'll even put a little cut in there just to give it that relief cut, because then as you can see, like as I move my fingers, you're putting shear load in the joint. So you just a little bit of zigzagging in there really puts a tremendous amount of strength in the joint. And you can actually, I mean, you can take a part and weld it together and it will be as strong as a part that was built in one piece. So yeah, this part, I'm going to do some tack welds on the back side of this part, just to kind of hold it together. And then once I get a tack weld, I'm going to start to complete the weld on the top of the part. So I've got a couple just pieces of wood here that I'm just using to set this on so that I can get this lined up and have this sit flat here. There we go, just like that. I'm not really going to worry too much about the alignment, because this is just a junk part that's going right back in the garbage when I'm done with it. So, and of course, you know, you might want to use some clamps and brackets and whatever to hold this as you need to. Just get it in a comfortable spot, which is difficult to do with this part. This part, by the way, is polycarbonate. It's the Stratasys polycarbonate material. So I'm just going to make a little tack mark in here. I'm just going to put that little dot of the material in there, and I'm just going to kind of smush it down. And now here's the beauty of this when you're doing these tack welds. If you didn't get it exactly where you want it, or the parts are shifted a little bit, or they're misaligned, you can actually go back and heat up that tack mark again and remelt it. And you can kind of move this around and adjust it and get it where you want it. So that's solidified. Sorry if this is hidden from the camera, but this is how I need to hold it so I can do this. So just another little tack mark there. And you see me pushing down on this weld bead with my thumb with the tip of my finger. The plastic is still molten, or it's still, it's past the glass transition point, so you can deform it. I can still deform it with my thumb for just a second or two after I finish welding it. So I'm actually using my thumb and I'm pushing that tack bead into the part. It's hot enough that the plastic is still melted, but it doesn't burn my fingers. You might want to use a glove or put a piece of tape on your fingers. Doesn't bother me. And so yeah, using that advantage of being able to still reposition and move the part, when you're doing these little tack welds, you don't really need to worry about having the part be absolutely perfect in alignment, because you can still move it around. I'm just going to put one more on this end, maybe one more on that end too. And yeah, so on this one I'm not even really worried about having it lined up. And for this tack mark, I'm not really pushing in that hard. I'm just kind of putting a little material down, because I'm going to use the pressure of my finger to flatten it out and force it into the part. I'm just worrying about alignment right now. One more over here. Okay, so now I've got 1, 2, 3, 4, 5, 6 tack welds in here, and now, I mean, the part is solid. It's I mean, even just with those little tack welds, it will hold itself together, and now you can go to town on it. Now, plastic heats plastic shrinks a lot with heat. It expands a lot with heat, so the welding will actually deform the plastic slightly. Just like if you're going to weld a metal panel, you wouldn't take like a long sheet metal joint that you want to weld and just weld a line straight across it, because you're just going to warp the bejesus out of it. I don't know if that's a word internationally or not, but you'll warp the part pretty badly if you do that. So you want to weld it in small little sections and keep the heat concentrated in just little spots at a time. So actually, where I'm going to start one little one here and one little one here, and then here and here, and I'm just going to start filling in those gaps. So just like I said earlier, I'm holding the filament vertically, put some heat into the part, little heat into the filament, and once you can visually watch the part melt and watch the part filament, or watch the filament melt, and you'll get a feel for when it's ready. And yeah, so now I'm pushing downwards on this filament with a considerable force. I mean, it's probably maybe 3/4 to 1 kilogram of force that I'm pushing on this filament. So that's the weld bead that I just made there. And just like before, it's proud of the surface, so I can sand this flush later. Now I'll move over to the other side here and catch up where I went. And actually, another thing I'll show you. See, I messed up with the bandsaw here. That I kind of went off track and had to back up and recut because I didn't want to cut through this hole. So there's quite a bit of material missing out of here. I'm actually going to weld that shut. So that's another thing that you can do this hot air welding for, is not only to bond sections together, you can also do it for repairs. That like if you have a print imperfection in the part, like some support material embedded in the part or whatever, you can actually go back and dig it out with a chisel and weld that material back in. And the beautiful thing about this is I'm just using filament out of the material canister, so everything is the same material. You know, I'm not adding like glue or epoxy or something to it. I'm not adding a foreign material. So all of the material specs are the same. Any of the certifications for the material are all still valid. I should mention too that this hot air welding process does work with all FDM materials, all thermoplastics basically. The only one that's a little bit trickier is nylon. Nylon doesn't really like to weld very much. And the Ultim materials are pretty tricky too. They take a lot of heat, and the heat actually kind of deforms and discolors the part. So just continuing along there, and yeah, like I keep reiterating, I'm pushing down on the part to dig that filament into the part. I'm digging a channel out of the part as I'm going, and then melting the filament as I go to backfill that channel that I dug out. And it takes a little bit of practice, but you can actually get it so that the backfill is equal to the channel that you dug out. So when you sand this flat, it'll be perfectly smooth. There will be no indentations in the part. That takes a little practice to do. If you do end up with some indentations after you sand it smooth, because you didn't have enough backfill from your filament, you can just go back and weld a little bit more material in there and just keep going until you've got it smooth. So actually, to make this a little bit faster, I'm going to turn up my heat and my airflow. PC has a little bit higher melt point. So I turn this up to 3 and 3 on this gun. Your results may vary, so you'll have to play with that to find the right settings for you. This isn't a terribly fast process, but the real benefit here is that you don't have to wait for anything to dry. You don't have to wait for glue to cure. You know, literally 15 seconds after it's cooled down a little bit, it's done. You can see the difference that just turning up that heat, just that little extra bit helped of how fast I can go. And in fact, you know, I'm very out of practice in doing this. 5 years ago, if I was doing this, I would have been done with this part already. You know, it would have taken me like, you know, 5 minutes to do the whole thing. I'm actually going to keep turning this up a little bit. I turned it up to 4 on the temperature and 3 on the airflow. I'm just going to keep rocking and rolling here. So now this is that area that I dug out with the bandsaw. So you'll see how I'm just going to weld right over the top of that gap. And I'm just going to melt filament into that gap and just close it shut. So now once I got to that gap, I don't want to push the filament through the part. So I backed off on my pressure that I'm pushing down and just allowed the material to melt into that gap. And now, I mean, the material that I just welded in there has already cooled and solidified, so I can go right back on top of it and stack another bead on top of it to fill it up. There we go. That's how simple that is. That's really nice if you have imperfections you want to take out. You can just take a drill bit and just drill out the little piece that you want out of there, and then just fill that hole up with new filament. And you may or may not be able to see that on the back side of the part, that I've completely filled that gap, even just from one side of the part. And then of course I can go back and I can weld the back side of this part too if I wanted to. Typically what I do is we use a solvent bonding agent, so like Weld on 3 or Pro Weld or some type of plastic bonding agent, and I'll fill the joint on the back side of this full of that and make it completely, you know, filled. And that really dramatically increases the strength when you put that solvent in there. So I'm just going to close this one more gap shut. I think I'll just make this my last weld here. You can see what's going on. You know, I don't think I need to finish this whole part. Alright, so took a little break from the video. I did finish weld the rest of this joint, and then I sanded a portion of this joint just to show what it looks like after you've sanded that weld bead down. Now it'll pretty much always show kind of a witness line. You'll always be able to tell where that weld is, unless of course you're going to paint it. But yeah, I mean, you can make a really nice smooth part. I mean, that's basically ready to go into primer and paint, or just be used as is if the aesthetics and finish aren't detracted. Now, I intentionally left this in there. I think it's difficult to see on the camera, but I do have one little low mark here where I didn't completely backfill and level out the part. So that would be an area that I would go in and weld a little bit of extra material in and sand it flat to make it flush. So yeah, hot air welding, that's really all there is to it. You can do really big complex parts. You can do all sorts of alignment joints and parts. Yeah, I really like it, and it works really well. Another couple things I did want to mention too is you can actually weld dissimilar plastics together. For example, this is ABS blue filament. This part is polycarbonate. And you'll see that the two weld together perfectly well. So you could, for example, if you needed two different material properties in a different part of the part, you could build one section in ABS and one section in polycarbonate. You could also do different colors. You could do one half of a part in blue and one half of the part in red and weld those two together. And then you could weld white filament in the joint so that you'd have, you know, 3 different colors on the part. So in any case, that's another thing that's kind of interesting about how this works. I did also want to mention too, this I believe is PCABS, I think. I'm not exactly sure. It might be ABS black. They're hard to tell the difference. But I wanted to show you that the black materials will change color a little bit and stand out quite a bit more than the white colors do when you weld and sand them. It's really more due to the sanding than the welding, but that's another thing to be aware of. The white material and ivory materials work really great, but the colored materials will show the weld joint more, which is not an issue if you're painting it, but it's something to be aware of if you're going to use the part in end use. But yeah, it's pretty easy. It doesn't really take that much practice to get a handle on it. Just a few hours of practice and you'll have it. Yeah, makes a really nice, strong part. I mean, it's, you know, yeah, works really well. Anyway, that's about all I have to say about it.